1967. A Marine fire base somewhere in the jungles near the DMZ. Rain's been falling for 3 days straight. Everything's soaked. Your boots, your gear, your rifle, and somewhere out there, beyond the tree line, there's a sniper team with Soviet Dragunov rifles, picking off your guys one by one, from distances your M14 just can't match. You're a Marine marksman. You've trained with your rifle until you know every quirk, every tendency. But now you're watching through your scope as enemy snipers operate with impunity at 900, 1,000 meters. Your M14? It's accurate to maybe 600 meters on a good day, 800 if you're lucky, and the weather cooperates. But the weather never cooperates in Vietnam. Here's what the brass won't tell you. Your rifle is losing accuracy every single day. The humidity, the temperature swings, the constant moisture. It's all working against you. Your wooden stock is swelling, contracting, warping, and every tiny movement of that wood against your barrel is throwing off your zero. So what do you do when your weapon can't reach the enemy? But the enemy can definitely reach you. If you're one particular Marine sniper, you head to the motor pool, find a spool of copper wire worth about 75 cents, and you change the war. This is that story. To understand what this Marine figured out, you need to understand what was going wrong with the M14 in Vietnam. The M14 rifle replaced the M1 Garand in 1959. On paper, it was a significant upgrade. Semi-automatic capability, 20-round detachable magazine, chambered in 7.62 × 51 mm NATO, a powerful, long-range cartridge. The rifle had an effective range of 500 yards for regular troops and could reach out to 800 yards in the hands of a skilled marksman. But there was a problem. Actually, several problems. The M14 was built around a semi-floating barrel design. The barrel was bedded in a wooden stock, usually walnut or birch. The idea was that the barrel would make minimal contact with the stock, reducing interference and improving accuracy. There was the barrel shank seated in the receiver, and then the barrel itself had a contact point at the front band. In the controlled environment of a stateside armory or a rifle range in California, this system worked reasonably well. The wood stayed stable. The contact points remained consistent. Accuracy was acceptable. Then you shipped that rifle to Vietnam. Vietnam's climate was a nightmare for wooden stocks. The humidity would regularly hit 90, 95, even 100%. Temperatures would swing from the 90s during the day down to the 70s at night. It would rain for days. Then the sun would beat down mercilessly. Then it would rain again. Wood is hygroscopic. It absorbs moisture. And when wood absorbs moisture, it swells. When it dries out, it contracts. This constant expansion and contraction meant the stock was never the same dimension twice. The barrel contact points were constantly changing pressure and position. Imagine trying to make a precise shot when your barrel is being pushed and pulled by swelling wood. Your zero, the point where your rifle is sighted in, would shift, sometimes by a little, sometimes by a lot. A rifle that shot dead-on yesterday might be off by several inches today. And in sniper work, several inches at 600 yards means the difference between a hit and a miss, between mission success and watching your target walk away. The standard military solution was glass bedding. You'd take the rifle to an armorer, who would remove the barrel from the stock, create a mold using fiberglass and epoxy resin, and create a perfectly fitted, stable bed for the barrel. This worked great. It really did. Glass bedding could cut group sizes in half. But here's the problem. Glass bedding required specialized materials, expertise, and time. You needed epoxy, fiberglass cloth, release agents, and someone who knew what they were doing. In a combat zone, these resources weren't always available. And even when they were, the process took time. You couldn't exactly take your rifle out of service for 2 days while some armorer performed delicate work in a rear echelon shop. Meanwhile, Enemy snipers were operating with SVD Dragunov rifles. The Dragunov SVD wasn't technically a true sniper rifle. It was designed as a designated marksman rifle, meant to extend the range of a Soviet infantry squad. But in Vietnam, in the hands of North Vietnamese Army snipers, or Viet Cong, who'd trained with Soviet advisors, it was deadly. The SVD was chambered in 7.62 form, a rimmed cartridge that had been in Russian service since the 1890s. Ballistically, it was roughly comparable to the 7.62 51mm NATO round. Similar bullet weights, similar velocities, similar energy downrange. The SVD had an effective range of 800 meters with its PSO-1 scope. That's 875 yards. In ideal conditions, skilled shooters could push it to 1,000 meters. But here's what made the SVD dangerous in Vietnam. It was designed for exactly this kind of environment. The SVD's stock was made of laminated wood, thin layers of wood glued together with the grain running in different directions. This construction made the stock far more resistant to warping from humidity. Yes, it would still absorb some moisture, but the cross-grain lamination prevented the kind of dramatic swelling and contraction that plagued M14 stocks. Soviet engineers had learned lessons fighting in every climate imaginable. From the frozen wastes of the Eastern Front to the deserts of Central Asia to the jungles of Angola. They knew wood moved with moisture. They designed around it. The result was a rifle that maintained its accuracy in the exact conditions where the M14 struggled, and North Vietnamese snipers knew how to exploit this advantage. They would set up at long range, 700, 800, 900 meters out, distances where a standard M14 with a warped stock couldn't reliably hit them. And they would methodically work over American positions. Officers, radio men, machine gunners, medics, high-value targets. Marine snipers would spot them through their scopes and range them. 850 meters. Within the SVD's effective range. Outside reliable M14 range, especially with stocks that had been in-country for months and were swollen from moisture. You could take the shot. Hope for the best. But hope isn't a strategy when someone's shooting back. The brass knew there was a problem. Reports came up from the field constantly. Enemy snipers engaging beyond our effective range. Request for improved sniper weapons. Urgent need for accuracy modifications. The official response was the XM21 program. Select M14 rifles would be sent back, accurized by armorers at depot level, fitted with national match barrels, properly glass-bedded, topped with leatherwood auto-ranging telescopes, and sent back to the field as XM21 sniper weapon systems, and the XM21 was excellent, truly excellent. With proper accurization, it could hold 1.5-inch groups at 100 yards. It could reliably reach out to 800, even 900 meters. But building an XM21 took time. Weeks. And there were never enough to go around. If you were a Marine sniper in some fire base in I Corps, you couldn't just radio for an XM21 and have one delivered by helicopter. You worked with what you had, which brings us back to that motor pool and that spool of copper wire. The principle behind what this Marine discovered was actually simple. Brilliant, but simple. The M14's accuracy problem came from the stock moving against the barrel. The wood swelled, creating uneven pressure. The barrel would touch the stock in places it shouldn't, or it would lose contact where it needed support. Every variation changed the harmonics of the barrel, the way it vibrated when you fired. Glass bedding solved this by creating a perfect, stable platform. But you needed materials and expertise. What if you could achieve something similar with materials you could find anywhere? Enter the wire. Here's what he did. He took copper wire, standard electrical wire, the kind you could find in any motor pool or comm shack, and he carefully wrapped it around the barrel at specific contact points. Then he bedded that wire into the stock. The wire served multiple functions. First, it created consistent contact points. Instead of wood pressing randomly against steel depending on how much it had swollen, you had wire maintaining specific points of contact. The wire was round, so contact was predictable. It wasn't going to change dimension with humidity. Second, the copper wire could compress slightly, providing a bit of give. This actually helped dampen some of the barrel vibrations without creating excessive pressure. Third, and this was the genius part, it was adjustable. If you needed to modify the tension, you could unwrap and rewrap. If conditions changed, you could adapt. Try doing that with glass bedding. The process was straightforward. You'd strip the rifle down, remove the barreled action from the stock, clean everything thoroughly, and in Vietnam, there was always plenty to clean. Mud, moisture, crud from the jungle. Then you'd identify the key contact points. On the M14, that's the barrel channel where the barrel sits in the stock, and the front band area, you'd take your copper wire and wrap it carefully around the barrel at these points. Not too tight. You're not trying to strangle the barrel. Just firm, consistent contact. Some guys used a single wrap. Others used 2 or 3, depending on how much the wood had swollen. Then you'd carefully set the barreled action back into the stock, with the wire creating the interface between steel and wood. The wire would settle into the wood slightly, creating a bedding effect. Finally, you'd reassemble the rifle and head out to test fire. And here's where it got interesting. The first test shots would tell you if you'd done it right. If the wire was too tight, groups would be inconsistent. You'd literally be stressing the barrel. If it was too loose, you wouldn't get the stabilization benefit. But if you got it right, if you found that sweet spot where the wire maintained consistent contact without excessive pressure, the difference was immediately noticeable. Groups would tighten up. The point of impact would stabilize. A rifle that had been throwing shots all over a 6-inch circle at 100 yards would suddenly settle into 2.5 inches. Scale that out to 600, 700, 800 meters, and you're talking about the difference between reliably hitting a man-sized target and consistently missing. But there was something else, something even more important for combat. The rifle would hold its zero. In Vietnam's climate, an unmodified M14 might lose its zero from morning to afternoon as the wood expanded in the heat and humidity. You'd sight in at dawn, and by noon you'd be shooting several inches off. That wire bedding stabilized things. The zero would hold for days, even weeks. Through rain, through heat, through the jungle. For a sniper, that was everything. Because now you could trust your rifle. You could dial in a solution for a target at 750 meters and know that your bullet was going where you aimed it. No guessing, no hoping. No, well, let's take the shot and see what happens. Precision, consistency, reliability, and all for the cost of 75 cents worth of copper wire. Word spread, not through official channels. This wasn't something that showed up in a technical manual or a Marine Corps bulletin. This was grunt-level innovation, passing from one sniper to another, from one unit to the next. Hey, you having trouble with your M14 losing zero? Try this. Snipers started modifying their rifles in the field. You'd see guys in base camps, rifles disassembled, carefully wrapping wire around barrels. Some used copper. Others tried steel wire. A few experimented with different gauges, different tension, different numbers of wraps. It became almost a point of pride. Your rifle, your modification, your technique, and it worked. Marine sniper teams that had been limited to 600, maybe 650 meters of effective range were suddenly confident out to 800 meters. In the right conditions, with the right ammunition, the M118 match round that started becoming available in '67, some guys were making hits at 900 meters. That might not sound like a huge difference. We're talking about 150, maybe 200 meters of additional range. But in combat, 200 meters is enormous. Think about it from a tactical perspective. An enemy sniper team with Dragunov rifles sets up at 850 meters. far enough that they feel safe from American return fire. They've learned that Marine rifles are good to maybe 700 meters before accuracy really falls off. They pick their spot. Good concealment, good fields of fire. They've got their range cards worked out. They know the distances to key points in the American position. They start working. First shot takes down a radio operator. Second shot wounds a squad leader. The Americans know they're being engaged. They know roughly where the fire is coming from. But when they range it at 850 meters, the assumption is they can't effectively shoot back with M14s, except now they can. The Marine sniper team, counter-sniper is what they called it, locates the enemy position. They range it, 850 meters. 3 weeks ago, that would have been a prayer shot. Maybe you'd get lucky. Probably not. But this rifle has been wire-bedded. It's been holding zero through 3 days of monsoon rain. The sniper knows his rifle, knows his adjustments, knows his wind calls. He dials in the shot, adjusts for the range, reads the wind, and in Vietnam, there's always wind, even when you can't feel it. It's there in the treetops. He finds his natural respiratory pause, squeezes the trigger. The 7.62mm bullet leaves the barrel at 2,800 feet per second. It's going to take about 1.2 seconds to reach the target. In that time, it'll drop approximately 26 feet below the line of sight, which is why the scope is adjusted up. It'll drift with the wind. It'll slow down due to air resistance, but the math works out. The rifle is accurate. The shooter is skilled. And 850 meters down range, the enemy sniper goes down. That's not just one kill. That's a tactical shift, because suddenly, the enemy can't operate with impunity at long range anymore. They thought they had a distance advantage. They don't. The Americans can reach them. So now what happens? Either the enemy snipers pull back, push out to 950, 1,000 meters, where they really are beyond effective M14 range. But at that distance, they're also pushing their own accuracy limits, especially with the standard SVD scope. Or they try to get closer, inside 700 meters, where they can be more effective. But now they're in the danger zone for American counter-snipers. The tactical calculus has changed, and it wasn't because some new wonder weapon was delivered from the States. It wasn't because of some high-level procurement decision or a shift in doctrine. It was because a Marine in the field, confronted with a problem, found a solution using materials at hand. That's the thing about warfare. The theoretical and the practical often look very different. You can have the best rifle in the world on paper, but if it doesn't work in the mud and humidity, it's useless. Conversely, you can have an adequate rifle that, with a simple field modification, becomes genuinely effective. The wire bedding didn't turn the M14 into a miracle weapon. It didn't suddenly make it better than a precision-built XM21 or M40, but it made it reliable. It made it consistent. It gave Marine snipers confidence in their equipment. And in combat, confidence matters almost as much as capability. Here's something that often gets lost in these stories. Innovation at the individual level creates ripples. That wire bedding technique didn't stay confined to one unit or one area of operations. Marines rotated through Vietnam on 13-month tours. Snipers would finish their tours and rotate back to the States, where they'd train new snipers. And they'd pass along what they'd learned. In country, humidity is going to play hell with your stock. Here's what we did. The technique made its way into unofficial training, not in the manuals. It would be years before anything like this appeared in official documentation. But in the actual schools, instructor to student, it became part of the knowledge base. It also influenced formal development. The armorers and weapons specialists who were developing the XM21 system weren't operating in a vacuum. They talked to snipers coming back from the field. They asked what worked and what didn't. And when multiple snipers mentioned field modifications involving wire bedding, the specialists paid attention. The formal glass bedding procedures that became standard for the XM21 and later the M21 incorporated lessons learned from these field modifications. The focus on creating consistent contact points, The attention to how wood movement affected accuracy, the understanding that environmental conditions in Southeast Asia required solutions that went beyond what worked stateside, all of this fed into the official programs. But there's something else worth discussing. The resourcefulness this represents. American military doctrine has always emphasized initiative at lower levels. In the Marine Corps especially, there's this concept that junior leaders, even individual Marines, should be able to assess situations and take action. Commander's intent gives you the objective. How you accomplish it is up to you. This rifle modification embodies that philosophy. The objective: effectively engage enemy snipers at long range. The constraint: standard M14, rifles losing accuracy in tropical conditions. The resources available: wire, basic tools, knowledge of how rifles work. The solution: adapt the weapon using available materials to restore and maintain accuracy. No permission needed. No requisition forms. No waiting for some procurement system to deliver specialized equipment. Just identify the problem, figure out a solution, implement it, test it, refine it. That kind of individual initiative has been responsible for countless tactical and technological improvements throughout military history. From soldiers in World War II welding improvised armor onto their vehicles, to modern troops 3D printing specialized equipment in forward operating bases, there's this continuous thread of, the official solution isn't here yet, so we'll create our own. And sometimes, often, actually, those field-expedient solutions work better than the formal ones because they're developed by people who are actually dealing with the problem every day. The wire bedding technique eventually faded as better rifles became available. The M40 sniper rifle, which was a bolt-action system based on the Remington 700, became the Marine Corps standard in the late 1960s. It was more accurate, more reliable, and its stock design handled humidity better. The Army's M21 system, with proper glass bedding, solved the accuracy issues for the M14 platform officially. But for a critical period in the mid to late 1960s, when American snipers were figuring out how to fight in Vietnam's unique conditions, the 75-cent wire modification gave them an edge they desperately needed. Today, the M14 is mostly retired from frontline service. It had a resurgence in the early 2000s as a designated marksman rifle in Iraq and Afghanistan, places where its range and power were useful in ways they hadn't been in Vietnam. But modern rifles, built with synthetic stocks and better understanding of accuracy principles, don't need the kinds of field modifications that Vietnam-era M14s did. But the story of that wire bedding modification remains relevant for a few reasons. First, it's a reminder that the best equipment in the world doesn't matter if it can't function in the environment where you're using it. The M14 was a fine rifle, genuinely good in many respects, but it had a fundamental design flaw for tropical use. The military eventually addressed that flaw officially, but in the meantime, individual Marines found their own solution. Second, it highlights the importance of allowing and encouraging innovation at the lowest levels. If there had been rigid restrictions preventing modifications to issued weapons, that improvement never would have happened. But because Marines were allowed, expected even, to adapt and overcome, problems got solved in real time. Third, it's a testament to the skill and knowledge of the people using these weapons. Coming up with the wire bedding solution required understanding why the rifle was losing accuracy, knowledge of barrel harmonics and bedding principles, and the practical skill to implement a fix in field conditions. That's sophisticated stuff, even if the actual materials were simple. The identity of the Marine who first came up with this specific modification has been lost to history. There's no official documentation, no award citation, no name in the record books. That's often how it goes with this kind of innovation. It emerges organically, spreads person to person, and eventually just becomes part of the collective knowledge. But somewhere in Vietnam, probably in 1966 or 1967, Some Marine marksman looked at his rifle, looked at his problem, looked at what he had available and figured it out. And then he shared it. And because he did, other Marines didn't die. Because they could reach out and engage threats that would otherwise have been untouchable. That's worth 75 cents of copper. Wire, that's worth remembering. Because wars aren't just won by the big decisions made in Washington or the expensive weapons systems that take decades to develop. They're also won by individual initiative, field innovation, and the kind of practical problem-solving that happens when people are confronted with challenges and refuse to accept that nothing can be done. A piece of wire, carefully wrapped around a barrel, maintaining consistent contact between steel and wood, dampening vibrations, stabilizing pressure points. It seems like such a small thing. But in the right place, at the right time, in the hands of someone who understood what it could do, it was enough to change the tactical equation. And that's the real lesson here. Not just the specific technical detail of how to improve M14 accuracy, though that's interesting in its own right. The real lesson is about resourcefulness, adaptation, and the power of individual innovation. In any field, in any challenge, the tools and resources you have available matter less than what you're able to do with them. Sometimes the simplest solution, implemented with skill and understanding, is more effective than the most sophisticated system that doesn't quite fit your needs. So next time you're facing a problem, any problem, remember the Marine with his 75-cent wire. Don't wait for the perfect solution to be delivered from above. Look at what you have. Understand your constraints. Think about the principles involved. And find a way. That's the legacy.